So we are going to see how to do the calculation for Ohm's law. Okay. So first of all, what are you going to write in your board exam answer paper? Okay, for the practicals. So first thing is you have to write the aim and then the formula. When you write the formula, you have to write this unit. Okay. Here also you have to write the resistance per unit length unit. Okay. And then you draw the circuit diagram and then you draw the model graph. So you make sure you take current along the x-axis and voltage along the y-axis, and after that you will write any 5 points. Okay, so short procedure you have to write. Once the procedure is over, next you have to draw the table. So in the table you can see there is serial number, voltmeter reading, ammeter reading. So voltmeter reading, here you have to mention the unit volt and here it is in ampere. Okay. And then comes the resistance R is equal to V by I ohm. That ohm is necessary. And then here when you are writing mean resistance, so you have to write the resistance value and then you will write ohm in the end also. So for this particular table, you can write ammeter here first because that is the known quantity, and voltmeter is the one which we will be calculating. So first you write ammeter reading, that is in ampere, and voltmeter reading, here it is measured in volt. Okay. Now after that, for example, let us say I'll give you a sample reading. So the first reading is, let us say, 0.5 ampere. For that particular value, the voltage is also 0.5. For 1 ampere, the voltage is 1 ampere. For 1.5, the voltage is 1.6. So this is just an example of how the readings will be. Okay, 2.0, here we will have 2.1. So what you have to do now is you use the calculator and you divide 0.5 divided by 0.5. So that is going to give me 1. Okay, and then 1 divided by 1 is also again 1. 1.5 divided by 1.6 is going to be 1.06. 2.0 divided by 2.1 is going to be 1.05. So once you have these values, what you have to do is you have to take the mean value. So how will you take the mean value? You will add 1 plus 1 plus 1.06 plus 1.05. You will get the value. So that value, okay, you have to divide by how many readings you have taken? 1, 2, 3, 4. So if you have taken 5 readings, you will divide by 5. You have taken 4 readings, that's why you will divide by 4. Okay, so what is 1 plus 1? 2, 2.06, 3.06 plus 4.06, 4. That will be 1, 1. Okay, so 4.11 divided by 4 will be equal to 1.02 ohm. Okay, so that will be the mean value. This is just an example. Okay, I'm once again telling you is an example. 1.02 ohm, and the length of the wire that we have is 40 centimeter. Sometimes it can also be 100 centimeter depending upon your practical observation. You have to select the value. You can ask your teacher. So what is the resistance length of the wire? So you will have 1.02 divided by 40, that will be equal to 1.02 divided by 40 is equal to 0.0255. Here the unit will be, this is resistance by length, so that will be ohm centimeter inverse. Okay, so make sure you write the unit everywhere, and even when you're calculating the mean value, here you have to write the unit, and this is in centimeter. Make sure to write centimeter here, and this will be in ohm centimeter inverse. Okay, and then finally in the result there are 3 results here. First one is the resistance of the wire is 1.02 ohm, and then the resistance per unit length will be 0.0255 ohm centimeter inverse, and then the relation between voltage and current is a straight line. So this you have to prove from the graph. Okay, so they will provide you a graph sheet. In that graph sheet you have to plot these values, these 4 values that you have taken. You will plot along the x-axis, you will plot the current. Along the y-axis you will plot the voltage. Okay, so now we will plot the graph. So along the y-axis you have to plot the voltage, and along the x-axis you have to plot the current. So as you can see, I have shown the table here. So in the table you can see what is the first reading in the current for the ammeter reading. So that is 0.5, 1.0, 1.5, 2.0. So what we can do is we can start the first value from 0. Okay, and then you can move on as 0.5, and this will be, sorry, 1 minute. This is 0.5, this is 1.0, 1.5 and 2.0. So same way here you have to plot the same thing, 0.5, 1.0, 1.5 and 2.0. Okay, so for 0.5 the value of voltage is 0.5, so this is the first point. For 1 it is 1, second point. For 1.5 it is 1.6. So 1.6 will be somewhere here, okay, not exactly at that point but somewhere above it. And then you have 2.0 and 2.1, so 2.1 also will be slightly above. So what you have to do is you have to join the dots. So once you join the dot, you can see that you are getting a straight line. Okay, so that is what we are trying to prove here. And if necessary, you will also calculate the resistance from here. So you will take the slope. So while taking the slope, this reading minus this reading will be delta V, and this minus this will be delta I. So the resistance from the slope will be delta V by delta I, which is equal to, so you can see here, this is 1.5 minus 1.0 divided by 1.5 minus 1.0. So as you can see, we are getting the answer to be 1 ohm. Okay, so that resistance from the graph also can be calculated. And don't forget to write the scale of the graph. So you can write scale is x-axis 1 unit is equal to, or 1 centimeter is equal to, so in this 1 centimeter length, how much you have plotted. So this current is measured in ampere and the voltage is measured in volt. Okay, so along the x-axis 1 centimeter corresponds to 0.5 ampere, and along the y-axis the 1 centimeter corresponds to 0.5 volt. So this will be the scale for the Ohm's law graph. Okay, so once you have done all this, the result from the graph, if it is asked in the question, you will write the result here. Okay, the fourth result will be the resistance of the wire from the graph is equal to, so you can write 1 ohm if it is asked. Okay, so depending upon your question, you have to attempt the thing. I hope it's clear. This is how you are supposed to do the calculation for Ohm's law.